That's very We'll just use webcam if everyone. I don't know. If you try and change back real quick. Yeah, I don't know why. Okay, why is this actually? Oh, we have to. Click next one there. Okay, it's a little bit slow. No, it just keeps hold on. Okay, don't full screen the speaker notes. Okay. Just leave it as a window. That's the biggest thing. Basically. Okay. All right. Should be fine. We're capturing it off the webcam.
Sure. All right, guys, we are ready to get started. Welcome to RITSEC Week 8. Make sure you guys join the Discord if you haven't, if you are new. I could hold this live for a second. Seems like we're all good. All right, sign in is dropped. Please sign in, guys. We will have pizza today, and we will be checking to make sure you guys signed in. All right, check the calendar. It is being updated. Check out the RITSEC mailing list as well. Now clap it up for the sponsors, guys. Clap it up for the sponsors. All right, thank you guys. Follow our social media. We're streaming on YouTube. Now for announcements. If you guys did a co-op this summer, scan this QR code. Good information for us. There is a WESIS general meeting happening on October 20th at 4 o'clock in the conference room, so I'm pretty sure it's 2730, featuring Alan Torrance, who's the executive director at JP Morgan. And he will be discussing career tips, AI at JP Morgan, and his journey and lessons learned. And now for Cloud Security by Lucas Frank.
Alrighty.
All you.
Hey guys, how's everyone doing?
Good.
Awesome. I'm pretty good. A little tired. Getting things started though. It's the end of the week. So a quick little intro. I am a 5th year cybersecurity student. This is my last semester here. I play a little soccer. Okay. I play a little soccer. There's a couple pictures. That's me in Central Park next to the Balto statue. Me on the way back from work. And then I had a chance to go to the One Piece Cafe in California this summer. So that was pretty fun. What we're going to be talking about today is we're going to be talking about what is the cloud, why would you choose the cloud model and some concepts, cloud services, how to access the cloud, network security groups and firewalls, IAM and KMS, and some cloud threats. And I got a little bit of a cloud threat demo for you guys, so we will get to that. So what is the cloud? It is not just a cloud in the sky. You're going to be thinking more like a big data center hosted by big companies like Amazon, Microsoft, Google. They have all the hardware. You are just using their hardware to provision instances, provision services, things of that sort. You're shifting more from an on-prem infrastructure to a virtualized infrastructure. And the responsibility of that infrastructure is shifted from the from you being the on-prem people to more of Amazon, Microsoft, and Google. So why would you choose the cloud? The big thing that they want to get across is that they have reliability, availability, consistency, transparency, and efficiency. Reliability is how reliable their services are. So their operation without failure. This is why you see things like service level agreements where they talk about 99.999% uptime. And if you do the calculation, that comes out to be like minutes of downtime per year, which is absolutely crazy. Availability, this is like how accessible and operational the services are if things do go wrong. Consistency, so if I log into my AWS instance in Rochester and someone logs in California, you're not going to have any real changes to the data. You both are seeing pretty much the same thing. Transparency is how complex the system is and how much that is obfuscated from the user. And efficiency is maximizing the performance. This is things like scaling, how resource allocation gets across your services. There's two different types of scaling. You're going to have vertical scaling and horizontal scaling. Vertical scaling is going to be talking about, so I have one instance and you're going to provision more resources for that specific instance. Horizontal scaling, this is when you have multiple instances or one instance that gets spread out across multiple instances. So you spin up more services just to deal with a specific load. So a couple different cloud models that you guys are going to hear are private cloud, public cloud, hybrid cloud, and multi-cloud. Private cloud is like, this is more like a dedicated environment for organizations. This is when you don't want your data touching any other customer's data. Think classified information, think stuff that governments would operate on. Public cloud, this is when multiple different organizations are dealing with like the cloud hardware. So if a bunch of different people in this room spun up AWS instances, we could be using the same hardware. It's just dependent on like how those resources are allocated. Hybrid cloud, this is when you have on-prem infrastructure and cloud infrastructure. I've seen this happen a lot with Active Directory setup. Azure actually has a built-in function called Azure Arc where you can sync an on-prem Active Directory network to something that is to your cloud Active Directory deployment. It's called Entra ID on the cloud. Multi-cloud, this is when you're dealing with multiple different cloud providers. So you have AWS, Google, Azure, all working in tandem. I have seen 3 cloud providers be put into use, but it adds a level of complexity that even the people running the network don't necessarily understand everything about it. So best practice, stick to 1 or 2. And usually this happens if you buy services in one cloud provider and then you buy services in another cloud provider and you want to use those 2 different services. But most of the time, if you have a service in one cloud provider, there's most likely an equivalent in another cloud provider. So you try and keep it as not as complex as possible. So a couple cloud concepts we're going to be talking about. You have compute, storage, networking, and security. Compute, that's what's actually going to be running your applications. This is how you provide processing power for your apps. This is virtual machines, containers, serverless functions, and they operate on a pay-as-you-go model. So how much resources you are using, that determines how much you guys are going to be paying for your resources. Be careful, you can rack up a lot of expenses. It is very possible, and it is very easy too. Storage, this is going to be holding your data, so it's accessible anywhere. You're going to store files. This is like databases, backups, or logs. There's a couple different types of storage. So you have object storage, block storage, and file storage. Object storage, this is like for files, images, backups. Block storage, this is virtual hard drives. File storage for shared access. If any of you have taken like SysAd1, you guys have set up a file share. Similar premise. Networking, this is going to connect all of your cloud resources efficiently, and it controls how data travels between users, apps, and cloud services. So think of VPC, which is a virtual private cloud. This is still operating in the public cloud, but it's an isolated network. VNets as well, subnets, load balancers. Load balancers is basically saying you have a bunch of traffic heading into your service, so you're going to direct it in a way that it's not going to cause something to crash. VPNs and gateways. There's also security. So this is what's going to protect your data, applications, and infrastructure. When it comes to security, though, there is something called a shared responsibility model. The shared responsibility model basically determines how much responsibility you as a user of the cloud environment hold over what is in your cloud. So the cloud provider secures the entire cloud while you secure what is in your cloud. Think IAM, so this is Identity and Access Management, KMS, and monitoring and logging. So the big 3 that you guys are going to be hearing when you talk about cloud is platform as a service, infrastructure as a service, and software as a service. These are different cloud computing services that are offered at different levels of abstraction. And depending on which service you use, the cloud provider manages the responsibility shifts between what the cloud provider manages versus how much you actually control. So platform as a service, this is more of a managed platform where devs can focus on writing code, what kind of data goes into it. You're not managing the servers and apps necessarily, but the provider manages the infrastructure, OS, runtime, and patching. Infrastructure as a service, this is your virtual machines, storage, and networking. You control operating systems, applications, and configurations. You kind of have the most control over infrastructure as a service when you're using a cloud provider. Think of it like renting an apartment. You bring the furniture and decide how you want to set it up. Software as a service, this is a complete package. You are buying a product and you actively deploy it on your cloud environment. So you're just using the app. The provider handles pretty much everything else. So the way I like to look at it is like cooking a pizza. On premise, you're cooking pizza at home. You have all the ingredients, you have the oven, you bake it yourself. When you shift to something like infrastructure as a service, you're cooking in someone else's kitchen. So you go to Domino's and you cook there. You use their tools, you use all their infrastructure. Platform, you customize a half prep pizza. You already have the dough, sauce, cheese, and then you just kind of put on the toppings. Software as a service, pizza delivered directly to your door. So next up, accessing the cloud. So you have a couple different ways you can access the cloud: web portals, CLIs, and APIs. So web portals, this is the most basic and what I would say you have a lot of control over, and it's not super complex. So you have an AWS Management Console, Azure Portal, and Google Cloud Console. You would log in as a user or using your root user email. And there are also CLIs. These are command line interfaces that you download to actually interact with your cloud environment. Major cloud providers all have a CLI tool. Most things you can do in the web portals, like the management console, you can do in the CLI. It just requires a little bit more tweaking. In the security with those, you have authentication, authorization, encryption, and auditing. So the authentication comes with your password, IAM, or API key. I didn't mention this, so APIs, this is like if your code wants to interact with your cloud environment, you would use APIs to actually communicate with your cloud environment. Authorization, so is the user you're logging in as, what permissions do they have, and what type of policies are set in place on your environment, like can you create or destroy instances, things of that sort. And encryption, TLS and HTTPS. Auditing, who's logging in and when. I got a quick little demo actually to show you guys of a AWS console we can actually look at. Okay, actually, we'll go through it later. Sorry, guys. So next up, we're gonna have network security groups. This is gonna be how your traffic flows throughout your infrastructure. Think ports, protocols, and actions. It's filtering traffic. It's not necessarily a firewall and pertains mainly to the resource you are applying it to. So you have a source IP, destination IP, port, and protocol, and then you allow or deny it. Best practices: incorporate an implicit deny. You want to have principle of least privilege, and principle of least privilege is the best way to go about setting up a network security group. So firewalls, this is going to be your first line of defense. This is protecting the perimeter. Filters traffic between trusted and untrusted zones. You have different types of firewalls. You have a network firewall, application firewall, and a next-gen firewall. Next-gen firewall is somewhat of a new concept. It adds like IDS, IPS type capability to your firewall. Network firewall, that's operating at your layer 3, 4 IPs, things of that sort. Application firewall, this is to prevent like known attack vectors against your web app of that sort. A couple types of firewalls. So AWS has Firewall Manager, Network Firewall, and Web Application Firewall. Azure has Azure Firewall and a Web Application Firewall. These firewalls are software based, so they're managed by the provider and they scale automatically, and they integrate with your services that are running in the cloud. So network security groups versus firewalls. Network security groups focus more on the resource rather than the entire cloud infrastructure. Network security groups are lightweight. Firewalls provide like deeper and centralized inspection against external threats. You're going to want to use both if you set up infrastructure on the cloud. These tools work in tandem with each other to provide layered security. This is a term you're going to hear a lot: layered security, defense in depth, things of that sort. Next up, you're going to have IAM. This is your authorization mechanism. This is your identity and access management. Users, groups, roles, things of that sort. Prevents unauthorized access, prevents like unauthorized creation of services on your, anything you do on the cloud is going to go through IAM most of the time. Are you allowed to do this? Enforces principles of least privilege and make sure everything you're doing on your AWS or GCP or Azure is allowed. One second, guys. Trying to get the demo going one more time.
Just try to share something.
Okay, I got it. Sweet. Okay, so this is a quick little demo of what an AWS console home would look like. So as you can see, what I was trying to show you guys earlier is the region we are in is the US East 2. And what's interesting about these regions that they have something called availability zones. This is to allow for redundancy in a case things go wrong in one place, another availability zone can kick in. They're still in the same region though, but they are physically separate data centers within that region. So when we're looking at IAM, so I have one user group right here, and the permissions set for this user group are going to be these permissions. And the reason I have these set up is because I use Terraform on this AWS environment, and I need to have a user that has the necessary permissions to actually interact with my environment, create resources. So if we check, these are the default permissions that allow that to happen. Look at IAM, see one user, and then whenever you create a user, you assign that role to it. You can assign them like single-handedly, saying like, okay, this user has this permission, but it's better to define roles. Another thing that I wanted to go over is you guys, this access key right here, whenever you're using a CLI and you want to specify a user, you want to use an access key, and when you configure that access key on your system, there's going to be an access key and a secret access key. These credentials are actually stored in your user's home directory. It's a hidden directory. I don't know if it's different for other cloud providers, but I know for AWS, it's a hidden directory called AWS and has credentials that that specify that user. Okay. So next up, we're going to be talking about a KMS. This is how you control your encryption on your environment at rest and in transit. In transit, you're managing your encryption keys this way, and provides you the possibility for envelope encryption. So you have data keys that actually encrypt your data, while you have a key encryption key that encrypts all your keys. You should be constantly rotating your keys, so this provides an easy mechanism to actually rotate your keys. And on your environment, so an S3 will have can have a key like specified by your KMS, or you can use the default encryption on the S3 bucket. So a couple cloud threats we're gonna be talking about: misconfigured storage bucket, stolen credentials, publicly exposed services, or lack of MFA. Pretty common attack vectors, not only in cloud but everywhere else. Misconfigured storage buckets more look at like overly permissive actions publicly exposed services, misconfigured network security groups, or firewalls that aren't necessarily configured properly. So I'm going to be taking a look at one challenge from an intentionally insecure cloud setup. So if I take a look, sorry. Okay, so this is an intentionally insecure cloud setup, and we're going to be going through level 1 right here. This is just going to be, it's called Buckets of Fun, and we're going to be actually exploiting a intentionally insecure bucket. So first step is we want to figure out the IP of flaws.cloud. So if I'm going to actually switch this up. Sweet. Okay. So let's open up a command prompt. Oh, and taking a look, we can also take a look at the hidden directory I was mentioning earlier. It's going to have config, and if you set up your user with that, it's going to have a file specified credentials. So first things first, we want to figure out the IP of flaws.cloud. So we're pinging flaws.cloud. Next step is you want to see if we can visit that IP directly. As you can see right here, it takes you directly to the S3 bucket page. This most likely means that this is a static site hosted in an S3 bucket. So what we can do right now is actually do a reverse lookup of that specific IP that we found. And we can see right here, S3 website US TAC West TAC 2.amazonaws.com. So we figured out from this reverse lookup this this region that we're going to actually want to be messing with. So from here, we can see that there's a bunch of different directories. So if I click on hint1, it takes you to hint1.html. My thinking is that there's probably a hidden page that we need to find by enumerating the S3 bucket. So if we can actually directly interact with this S3 using the AWS CLI, list the contents of that S3 / flaws cloud / region. So as you can see here, unable to locate credentials. So we are not able to actually interact with this. However, how many of you guys know about anonymous logins with like file transfer protocol, things of that sort? Awesome. At least a couple of you. So if we add another thing called tag no sign request, we actually can get all of the hidden directories that we may not necessarily find. So as you guys can see, there's hint1, hint2, hint3, and then the index.html. However, there is this secret dd02c7c.html. So why don't we try and visit that guy and see what happens. That is the secret file that we found on the S3 bucket static site. There are multiple levels to this, so you guys can go as far as possible. Going back over a couple of these other intentionally insecure setups, CloudGoat, it's just a GitHub that provides you with a set of challenges that you can complete. Coalfire Research Platform as a Service Cloud Goat. It's a Salesforce instance that you can actually intentionally exploit. But other than that, guys, that is all from me today. Anyone have any questions? Okay. Okay. Well, that is it for me, but I thank you guys for letting me present today. Thank you. Thank you, thank you. I hit time? Sweet.
Alright, demo time. So this week's demo is a little bit different than usual. I had some trouble setting up actual cloud stuff that everyone could do easily myself, so I used ones that already existed. To meet the challenges, there's 3 of them this week. They're all a little bit trickier. The first one is through AWS. The other 2 are through something else that goes through AWS. So go through there. The challenges you have to do separately, and then when you complete them, get me on Discord, and I'll give you the flag for the challenges. They're all a little bit more complex than usual, but they're still easier challenges. So hopefully you should do them. Ask for help if you need any, and get good luck. Also, last week's challenges are still open for another week, and week 5 is finally closed with the write-up available in Discord.
Say something, I'm giving up on you. Hello.
Ooh, I saw that too.
Hello.
Hold on.
Me.
Everything I touch in my processes.
Hello.
I should be able to hear the music. Hold on, it takes a little bit longer for the music to. Ah, I hear it. Good.
Hello. I don't know. Go find someone else on e-board and ask. Okay. Hi guys. We're gonna start news in just a minute. Make sure to tell everyone to come in here who's outside right now, please. Okay. I'll get started. Or should I? Oh, yeah. It's up now. It's good.
The audio is fine. You can start.
Okay. Hi guys. We're starting now. Sorry for the technical difficulties. So, if you're interested in presenting, make sure to sign up. Presentations.ritsec.club. I will say all like spots are pretty much filled for the rest of the semester. But if you're interested in presenting for next spring, I would start filling it out. I'll send out actually I'll fill out make a new form for spring specifically, but that'll come out soon. Also, if you're interested in blogging, make sure to make a blog post, sign up. If you make a post, you'll get some points, get some rewards. And if you haven't signed in already, please sign in. I'm sure you have. Make sure to join the Discord, check the calendar, and join the mailing list if you haven't. And also follow our social medias. And as well, please clap it up for the sponsors. Okay, thank you. All right, just some announcements. There's a WESIS general meeting featuring Alan Torrance, an executive director at JP Morgan, on October 20th at 4 p.m. So if you're interested, you should pull up. Now, just some quick news before I get to the presentation. Okay, first up, we got F5 cybersecurity breach. F5 is like a cybersecurity company that like produces devices, and recently there was like a leak essentially where some threat actors found source code. They haven't actually like done anything with it, but apparently they've just like had it and have been waiting to do something. Um, as a result, CISA, like the Cybersecurity Administration for the government, mandated like a bunch of changes and stuff, making sure that any like organizations that are using these devices have to go through like a pretty rigorous process of like fixing them, quarantining them, getting rid of them. F5 responded with some changes to security, uh, but yeah, nothing has come of it yet. We are waiting to see if some exploits or vulnerabilities are dropped at some point. Also, apparently there was a vulnerability exposed with framework laptops recently. There's only specific models which were affected, which I'll show on the next slide. But essentially, it's like this vulnerability with this memory modify command. So if you're able to get like a shell with like one of these laptops, you're able to essentially just like overwrite the like whatever is like validating secure boot, and so you can just like completely get past that, and as such just like put a rootkit on there and just like get access. So here's the models that have been affected. They're in the works. Framework is in the works of fixing them. Most of them have been fixed. There are some that are planned. What does this mean for you? Like probably nothing. It's like not really that big of a deal, but still interesting that it happened. It was more of like an oversight on Framework's part. There's some of my sources, and now to get in it, we have Vinod from Equifax presenting on architecting a secure application in the cloud.
Make sure you're unmuted on the Zoom.
Yeah, unmute it.
There you go.
One moment. Did you unmute it? Oh, hello?
Hey,
Hey, can you hear me?
I do.
Can you see the audio, or not the audio, the video over here?
I do.
Okay, great. We'll pan the camera around to the rest of the audience in a minute, but we're just setting up the stream, making sure everything's set up right.
All right, and let me make sure I can indeed share my screen if I need to.
How's your day going?
Friday, almost there.
I feel that it's been a very busy week for a lot of us. There's midterms, jobs going on, all that kind of stuff.
All right.
Did you try screen sharing yet?
Not host isn't allowing share for this
Hold
meeting.
on. Yeah, let me fix it. Well, no, let other people sharing. Yeah, allow everyone to. Where? Oh. Okay, hold on. It's because this is my other account. I need to join. 1 second, sorry.
This isn't the host account?
No, it's because the host account is my RITSEC account, not this one. Okay, there's two of me. 1 second, sorry. Meeting info. Where is it? Where are the settings? How did you do this? Did it join from the right account? Let me make sure. Hold on. This isn't meeting info. Oh my god, what's happening? Hold on. This is why you don't run the Zoom meeting. Don't you have the actual like thing up there somewhere? It's because it's like the RITSEC account versus the RIT account joining, I think. You don't have to type your whole name. Yeah, you're right. Why does it keep joining with the other one?
Copy the link. And then, no, copy it.
Okay. Sorry about this. I'm used to a Mac. It's just some weird funkiness because, like, with our actual RIT accounts versus the club accounts.
Yeah, no, it's all good. Believe me, you'll be doing this for another 30, 40 years if you're entering the IT field. So
I feel like we should be better with this technical stuff, but there's always issues with meetings. Hold on, try that one.
Do your thing?
Yeah.
Okay, cool.
There we go. Okay, try now. It should be fixed.
yep, that did it.
Okay, great. Are you sharing? Oh.
No, almost there. Working on it. Give me a second.
Okay, no rush.
Is that good?
All right, we're all set. We can see it now. And
All right, awesome.
Can you rotate the camera for the rest of the audience?
I need to see myself.
Wrong way. Sorry. Okay. Can you see everyone now?
I do.
Okay, great. All right, I'll let you take the floor. Sorry about the rocky start.
No, it's all good. Hey everyone, happy Friday afternoon. I'm Vinod Nanapaneni. I lead the cybersecurity architecture and engineering group for Equifax. And today I'm here to talk about architecting secure applications in cloud. It is a very dry subject compared to some of the fun topics you may be exploring, the red team versus blue team and whatnot. So um, I will leave it a little open-ended. I will, please do stop me whenever you want to in terms of questions. I also have no understanding in terms of the knowledge you already possess. So if this is already covering areas that you already know about, please do let me know and we can just skip past that subject. Any questions?
I will say there is probably a variety of like underclassmen and upperclassmen. So
Okay.
I think there's probably a good variety. And if you have a question, just raise your hand. I'll come and give you the mic. So feel free to just at any point, look, without obviously interrupting. But yeah.
Okay. So how many of you have already worked in the cloud in terms of at least playing on by yourself in terms of whether it's AWS or GCP or Azure? Do any of you have any exposure to any of the cloud environments?
Looks like a few.
Yeah.
Like pretty small, not a lot.
Okay. All right. So then what I can then do is make this a little more generic and not to talk too much cloud specific, but obviously we can cover anything else if we need to. So fundamentally speaking, regardless whether it's your old school traditional data center based environments or if you're talking cloud, in the end, a generally secure application is considered to have three layers, three or more layers. The first layer in the is always referred to as a DMZ or an internet facing web tier. This is where you typically have your proxies, load balancers, your Apaches, Nginx, your web servers, right, that act as a front end to all the traffic that is coming in. And we do that because we do not want to obviously expose some of our sensitive assets directly into the perimeter. Folks who are probably trying to specialize in the red team side of things in terms of penetration testing will know the implications of having, let's say, sensitive systems exposed to internet. So that is something you do not want to do. And that's why you start off with non-sensitive systems in the internet tier, right? Right behind that is, now again, the first tier is always referred to as more of a public tier, right? And then you then have behind it two private tiers. The middle tier is where your actual business logic lies. This is where your application does the processing if you need to. And then you have eventually behind it an application tier, right? This architecture effectively allows us to isolate the most sensitive system, which is your database stores, away from public exposure, and you effectively have two layers before you can get to the third layer. This is generally considered the pattern for any enterprise level application implementation across the globe. This is an industry standard. This is what enterprise architects follow. This is what security architects follow. This is what you would see everywhere. There will be anomalies, but I don't want to go into that right now. The reason I bring up this architecture is everything that we talk from here on out will be based on this design. Everything in the world right now revolves around this three-layer design in a way, right? And one of the first items that you probably might have heard is the term defense in depth. It is to basically have more than one control protecting your asset. I'll take a segue here. A quick question. Anyone have, does the term control ring a bell? Do you know what I'm referring to when I say control? Would you like me to elaborate on that?
Yes.
Yes? Okay. A control is, in essence, a defense mechanism, and you would always want more than one defense mechanism to protect your assets against attacks. One of the most common control or defense mechanism is on, I would say, your EDR, your antivirus on your machines. That's your first layer of defense at a machine level. And then you could then think of your firewall acting as, or your local router at home is acting as your second layer of defense, where it is probably stopping all the scanning happening over the internet that would otherwise affect your machine, right? Defense in depth is effectively ensuring that you have more than one layer of protective measures to ensure your systems are safe. The reason we do that is you always have to assume that one or more controls will or potentially fail at any given point of time. So if you had more than 2 or 3 controls, even if one of them was not working, for example, hey, my antivirus is out of date, it was not keeping up with, maybe you were using a free version of antivirus, and then, we're talking about a new virus variant that came out in the last month. The antivirus package does not know how to catch it. And should that actually get through the defense and onto the machine, it is definitely going to infect the machine. Again, I'm using a terrible example, but I hope you get the idea, right? So defense in depth is something that you would hear a lot. Generally, when we say outside coming in, again, from internet coming into your network, they're typically perimeter firewalls, network-related firewalls, server-related firewalls, and then eventually you have antivirus on the server itself, providing you that multiple layers of defense, hence the depth. The other thing you would see a lot, especially when you start working in the cloud, is the concept of a shared responsibility model. And very briefly, I would say this is where your AWS or Azure or Google Cloud, they own the infrastructure, they manage the infrastructure for you, they own the facilities, the data center, the racks, the network cabling and racking and all that, right? In that model, they own the physical responsibility of protecting the physical infrastructure, ensuring nobody can break into the data center, nobody can, physically plug into a server and try to copy the data, and so on. And from that point on, everything that we deploy in their cloud infrastructure then becomes our responsibility. Now, within that, there are 3 different layers, what we typically refer to as infrastructure as a service, platform as a service, and software as a service. For example, your Gmail is software as a service running on Google's infrastructure. And for software as a service, all you do is you open up your browser, you hit a URL, you are in that application, whether it's your Gmail or Google Chat or Google Calendar, right? Platform as a service is one level down, where you would get to write your code for your own application and you get to deploy it in certain scenarios. I'm trying to think of a couple of good examples. Have you heard of Lambda by AWS on Amazon Web Services, Lambdas or Cloud Functions? Any of those names ring a bell?
I don't know
Where
about. I think some people in the room have. Yeah, I have. I know with Lambda, it's like you essentially give them your code, and then they sort of will like scale it for you.
Exactly. So Lambda is the platform as a service where you don't have to worry about the operating system, the server, anything at all. You have a code, you deploy it, AWS runs it. The difference here between compared to the Gmail example is Gmail, the code is theirs. With platform as a service, the app code is yours, right? So you deploy your application there. The third layer, actually, I should have probably kept clicking this. So if you notice in the SaaS layer, the only thing we control is the data. That is your Gmail account. So your emails, your data, there's no other control. Whereas in platform as a service, you get to deploy your application and then you're interacting with the application and the data of the application. And the third category is infrastructure as a service. This is where you would deploy a virtual machine itself. It's like deploying with a full-blown machine with an operating system, and you do everything that you get to do. The key difference with infrastructure and platform as a service is with infrastructure, the operating system upkeep. If it's a Microsoft operating system, you have to make sure you're patching every month, keep up with the patch cycle, you make sure you have your antivirus and so on. So one of the reasons PaaS is beginning to pick up momentum, there's a lot of PaaS usage in the industry these days, is because you don't have to worry about patching and maintaining the underlying operating system. And the cloud provider, whether it's AWS or Google or Azure, they do the management of the operating system for you. Any questions so far?
I do not think so.
All right. We will then move on to some more foundational concepts. One of the ones I would say is the identity and access management. Everything in cloud revolves around IAM. IAM is the first line of defense. IAM is the last line of defense. Whether it's the pen testers trying to break into their environment, somebody's environment, they would be trying to leverage IAM models. Most of the attacks these days are IAM based. The Capital One incident that happened 4 years ago was related to IAM. Misconfigurations around assets is also related to IAM. So if there is one area that you could really benefit with good knowledge is IAM, right? You would also hear concepts like zero trust that show up in the same area. The idea of zero trust is to ensure that you don't trust any session at all, and that every session has to uniquely identify itself before it is granted access to do any activity. And the least privilege also goes along with IAM, right? Do not give users more permissions than they need to. Keep the permission levels minimal for their required job function. Any excessive privileges can eventually lead to loss of data should the privileges be abused or if the identity is compromised. Yeah, the IAM account is compromised. You probably heard enough about the industry recommendations about having MFA enabled. MFA is one of the core tenets these days for every single application and capability out there, whether it's SMS-based authentication or using app which generates a random 6-digit code. MFA is the one way to ensure the app accounts are kept safe. Depending on your exposure around cloud IAM, I can skip past the temporary credentials and actually move on to the secure network design. Any questions so far?
I don't think so, no.
Okay. Is the content resonating or am I really off target?
No, I think I don't know about everyone else, but I mean I see some nods. I think it's interesting. I have like some familiarity with cloud, but it's definitely good to sort of get like more of a basis than I already have.
And I do have to say the architecture and engineering practice in the cloud, especially around cyber architecture engineering, tends to be a little more drier compared to your typical red teamers or blue teamers trying to look at logs or trying to execute pen tests. This is something that folks generally transition to once they've worked in a specific area for a few years. So once you start working, you don't get to become a cloud architect on day one, right? So I'm sure if you would like me to cover a different subject, I can come back with a different area, and I'm just putting options on the table for you folks. Yeah.
Sure, I appreciate it. I mean, I will ask actually, like, do you
Yeah.
enjoy then working like as a cloud
I
architect?
absolutely love this. I've been doing this for over 15 years. I've actually started my career as a Java programmer about 20 years ago. I did not like Java programming, so I ended up becoming a Unix administrator.
That's fair enough.
Right, and from that point on, I transitioned to becoming an IT architect. I back in the day, we used to rack and stack and cable the networks and servers ourselves. So we had a little bit of more understanding of how the network architecture worked. And from that point on, I kind of transitioned into architect and eventually becoming a cyber architect and now leading the teams around architecture and engineering. So I would generally say as long as the fundamentals around ports and protocols and the tools around how HTTP works, right? How FTP works, right? And if that knowledge is gained at the stage where you're in, you will have many opportunities to transition into any role you would like on the cybersecurity side. Cyber is one of the areas where you could be a pen tester today and transition to, let's say, a blue team acting on the defense side of things, looking at logs in a span of 2 years. The knowledge you gain in one domain will act as like a significant strength in another domain. That being said, I know I'm reading a little bit of the content I'm supposed to present, but if you guys would rather talk about everything more generically, I'm happy to do that as well.
No worries. I think everyone here is interested in like literally anything cybersecurity related. So
Okay. Yeah, so one of the things that we do typically is to ensure the fundamental network design is secure, because along with IAM, network plays a key role. And when applications are deployed in the cloud, we do ensure that we enforce appropriate segmentation. Going back to the concept of public and private, great care is taken to ensure all the assets are deployed only in like a non-internet exposed private segment, and only the applications that need internet exposure are deployed into the public subnet, and that too by using proxies or load balancers. Yeah. And then, yeah, obviously make sure we're configuring the firewalls to only allow the required ports and nothing more than what is needed. The other thing you will hear in the industry a lot is around DevOps or DevSecOps. There's fundamentally not much difference, and security has also adopted DevOps. And that's where DevSecOps comes into play, where now security is deployed as code. So going back to the earlier example, if somebody were to deploy a Lambda to run a web application, the code protecting the Lambda in terms of the configuration itself is also packaged as part of the Lambda code and deployed together in production at the same time. So having a strong understanding on DevOps will also help gain an understanding how security would package into DevSecOps and deliver secure applications in cloud. And yes, encrypt everywhere. Make sure the data is encrypted at rest, encryption in transit, everything over, you probably know, use only HTTPS, do not use HTTP, because HTTP is susceptible to man in the middle, and you want to ensure you're visiting and communicating traffic only on encrypted protocols. How many of you have exposure to secrets, and do you know what secrets mean, and why do we need to protect secrets securely?
like everything like 50-50 maybe.
Okay. So when you develop an application, that application very likely has to interact with the database, and the database most of the times would have a username and a password. And current practice is generally to include, not current, we always historically used to include the username and password in a configuration file and just deploy it on the web server along with the code. And anybody who could get to that web server could then access that config file and then go exploit the database. It is for that reason, it is strongly recommended not to store any sensitive information that could lead to a bigger compromise in configuration files and in plain text. And that is where secret managers come into play. Now, within each cloud, there are secret managers that are provided. Google has their own secret manager. They call it KMS. AWS also has a KMS, in turn also referred to as a key management service. This is where you put in your secrets, and at runtime, when the application needs to access the database, it retrieves the credentials from the secret manager and connects to the database. That way, the application does not know what the secret is ahead of time, and only folks who have access to the secret manager know ahead of time. And that can then be limited to 1 or 2 people, because you don't need to share the key broadly. You don't need to put in a config file. None of the developers can see it. None of the admins can see it. It is definitely one of the ways to ensure that the key to the database is kept secure. And lastly, I think I probably have 6 more minutes here.
I mean, you can go like as long as you want. There's plenty of time after as well.
Okay.
No
Um,
rush.
So once the application is deployed, and I think this is the part where it might really intrigue you guys, we tend to have, every enterprise tends to have a dedicated security monitoring team, right? And within that security monitoring, there are different layers. You have your typical SOC, Security Operations Center, which is generally shift-based. You have 24/7 coverage in that SOC, and their only job is to monitor for events, protect the enterprise against threats. And once the SOC gets an alert, and they do their initial triage, and once they confirm that it is indeed an event, they typically engage the incident response team. And that's when the incident response team actually does another round of review, and if it is a valid incident, they then just initiate the incident response protocols. The reason I'm giving that background is, in the end, in cloud, everything revolves around logs. We today consume around 20 to 30 terabytes of logs a day, and that is not including logs that we put into cold storage. And if I were to translate that into billions, I'm talking somewhere around 10 to 15 billion log rows per day in terms of the volume, right? And our systems then comb through, and this is where you probably heard of some of the industry products like Splunk and Azure Sentinel, and this is where the dedicated SIEM products come into play, where these logs are then fed into the SIEM, and that is where your cyber analysts then start writing detections around specific threats. Those detections, when a particular event is found, and when I say event, I'm really referring to an anomaly where, again, if I were to use a simplistic example, you do not want to see a user that does not belong to a company show up in one of the logs, for example, right? Those events then trigger to SOC, and then from that point on, the protocol follows. As I said, logging is, if anything, the only and one of the fundamental detective controls or detective capabilities that are provided in cloud, and it is like immensely helpful. It is actually it is required, and in some cases it is even obligated by federal requirements depending on which regulated industry you're operating out of. Financial services, it is an absolute mandate that we do a certain level of logging. And I would say that is one of the reasons probably our logging levels are so high. As I said, we process almost 20 to 30 terabytes on any given day from a volume standpoint. And we have a team of about 50 analysts across 3 countries. And I would actually say 3 different time zones to ensure 24/7 coverage. In terms of watching the platform, if you will, and then responding to any incidents. And 99% of the times, the alerts are false positive, where should an actor get through, and when we say actor, it could really be a benign virus, right? That is where you're going back to my earlier comment around defense in depth. If the malware defenses are working properly, if the antivirus is up to date, it is working properly, it will act on it. It will merely throw an alert that, hey, I found a suspicious file. I took care of it. You don't have to do anything else. And even that, in the end, is a log record, because in the end, we're talking about 30 to 40,000 servers, and we're effectively talking about 30 to 40 people protecting those 50,000 servers. So the protection measures have to work at scale, and that is where the defense in depth combined with having appropriate monitoring protections is key. And that's the example I was referring to in terms of automation. Given the limited capacity that we have in terms of the personnel, there is no way we can tend to each and every alert that is generated on any given day when we get hundreds of alerts. And the automation around, especially with the AI, things have become, I would say AI has begun to play a big role in the cyber analyst space as well, where we proactively feed alerts into AI engines to look for anomalies. And if the alert is indeed a false positive or a true event that we need to act upon, and based on the response, we either auto remediate or auto close the incident, right? And lastly, should in an unforeseen scenario it be an actual incident, we will always have playbooks. That's what's referred to as a step-by-step plan to execute upon should there be an actual incident. And I think generally when an incident happens, those are very high pressure scenarios. There's a lot of stress involved for people who are actively working on the incident. And the one way to ensure that the appropriate steps are followed is to ensure that the process is well documented. And I would say I went through everything at a very high level. If there are areas that really appeal to you folks, I can always come back with a specific targeted conversation. But if you have any questions, please do ask.
I'll start just with some questions.
Yeah.
Just like if just like with the point that you were just on with incidents, I mean, is that something that you guys like go through a lot? Like, do incidents occur a lot, or is that like a like not that common thing that occurs?
Well, the definition of incident, I do want to clarify that, right? Do we have an actual incident? No. But do we have alerts that require us to validate whether it's an incident or not? We get a ton every day. Yes.
And also, like, can I ask a more like general question for like Equifax in general?
Sure.
So like with like the scale of the company and like all of the information that you guys deal with, are there a lot of like compliance standards that you have to meet that are like very strict?
Yes. Yes. So we do process credit card information. So we are obligated to meet the PCI DSS standards, right? For folks who sign up for, I would say, you want to look up your own credit score, you're putting in your credit card information to look up your scores. We process credit card information. So we do have to meet PCI DSS. New York State requires us to meet New York Financial Services Compliance Requirements. It's referred to as NYDFS. We have to meet that to do business in New York. We are required to meet SOX, which is the Sarbanes-Oxley for financial services firms. We have our own SOC 2, type 2 for our general infrastructure. So I would say, yeah, we do have quite a few compliance frameworks, including a framework from FTC, the Federal Trade Commission.
And like, do you think that like that directly affects like the architecture that you like develop and like your job, like compared to a company that would say like doesn't handle information like that? Is there a massive difference, would you say?
100%. A startup doesn't have to worry about all this.
And so
Absolutely.
like, sorry, go on.
No, I was going to say that 100%. The business and the requirements around the compliance dictate the measures we have to take to protect those assets. Yeah.
Okay, if anyone else has any other questions, feel free to raise your hand and I'll come and give you the mic. If not, I'll ask another question as well. Okay.
Hello, Havinod. That's how you pronounce
Hey.
it, correct?
You good? Yep.
Okay. Great presentation. We're holding our applause till the end. I had a question about, I guess, the like software as a service, infrastructure as a service. There are different models, and essentially there's some sort of like shared responsibility between the provider and the companies that are actually using this software or infrastructure, correct?
Yep.
If so, if there's like some sort of vulnerability or incident, if it's like actually a real incident, where's that line drawn where like who does the brunt of the work, I guess, to trying to remediate some of those issues?
Yeah. So it depends on where the incident happened. So obviously before we use a cloud provider, we do sign appropriate contracts, right? The indemnity clauses and so on. But let's say if the incident happened at a physical layer where somebody managed to actually get into the data center and hooked up their USB port and copied data out, that would completely be the responsibility of the cloud provider to remediate, notify the consumers who were affected, whoever's data was on that server at that point. They have to notify the customers and they will bear the brunt of the remediation. Now, on the contrary, if it has happened in one of our applications that we are running, that is on us and not the underlying cloud provider.
All right, thank you. Any other questions? I'm sure you can ask like anything. It doesn't need to be hyper specific. Yes? Well, okay, yeah. What are some tools or like resources that you'd recommend if if someone is interested in getting into cloud?
Nothing beats your own keyboard. AWS accounts are free to sign up. Get your parents' credit card and play. I mean, really, a Linux machine in AWS is less than $100 a month. But you get to play and explore. The hands-on knowledge, nothing beats that. And if you're looking for resources to help you understand what you do and how you go about, I mean, I'm not recommending, but some of the tools that I know, some of our early entry engineers use are, I believe, Code Academy is one. There are plenty, I would say, YouTube resources as well that let you just navigate your way into cloud, and nothing beats. You can sign up for an account for free. There's no cost to signing up an account and just poking around and just looking at things. Just make sure you're not downloading malware, because you would end up getting a call from one of the cloud providers' technical support teams. Because the agreement with any of the cloud providers is to not misuse their resources. So as long as you're not attempting to do something terrible, you would be fine.
Gotcha. Any other questions? I saw a hand up over here. Maybe. Okay, I guess I'll ask another question. So like over the past years, have you seen like a major shift in like how long have you been at Equifax?
I've been with Equifax 4.5 years.
Okay, I guess I don't know how long that like time frame is with cloud, but have you seen like a shift towards using a lot more like cloud as infrastructure?
The transition to cloud as infrastructure happened 10 years ago.
Yeah, so I don't know if that's.
We are now at an inflection point of moving to AI in cloud too. So there are not many firms that are still using the legacy on-premises systems. It's far and few. Many of the large enterprises have cloud footprint in one way or the other. And I would definitely emphasize the need to upskilling in cloud as the path to future, and mix that up with AI for sure.
Also, with like that, the like gaining prevalence with AI, do you see that like affecting cybersecurity jobs? Isn't like the job market in general, or like how people conduct their jobs?
Yeah, absolutely. For example, this presentation I created in Gemini because I'm not good at slides. So, is it everybody? I'm really talking about. Okay, I'll give you a great example. Pen testing, right? Back in the day, not when I say back in the day, I'm still talking 6 months ago, when pen testers have to go perform a test against an asset. They typically used to perform an effort. It's called the reconnaissance effort, where they go, you scope an asset and the environment, the footprint, the ports, protocols. You don't need to spend time trying to do recon anymore. There are plenty of AI tools where you can just tell it to go do recon for you, initiate attacks for you. It'll do everything and it'll generate the report for you. So I think it's absolutely vital that especially as upcoming grads, you embrace AI wherever you can, and look at it as your I shouldn't say peer, like your assistant. You have to adopt using AI as your assistant. We are using AI big time already, both in our defense approach as well. Like, we've automated all level 1 analyst roles to AI, where the AI looks at an alert, does the initial sequence of steps to see whether something is really false positive or not. And if it is, it then bumps up the ticket to level 2. That's already happening.
That's pretty crazy to think about. Do you think that like AI could ever do your job, or like a solutions architect at some point? Do you think that's possible?
I think it's getting close. It potentially could. Because as I said, I just had to type in the appropriate prompts for it to generate some recommended architectures and best practices, and here you go. This is everything AI generated.
Is that something that like you're worried about in the future, or like at least
No,
no?
no. But so that is where I would say the experience aspect of ours comes in. As much as AI can do, it cannot replace human experience. So this is why I would say, as long as we start adopting AI as our assistant and use that to improve our own productivity and our own pace and skills, you will be golden.
Okay, thank you. Any other questions? Okay, question over here.
Yep.
Do you ever worry that perhaps like you said that you're automating all the level one analyst positions? Do you think that there's going to be like maybe in like 10 years there's not going to be anyone to like move up to like more of a senior role because there's going to be less junior analysts being hired right now?
That is a great question. I do not have an answer to right now. It is definitely becoming a struggle for junior analysts. I can see that in the market. It is already materializing. But the difference, however, I would say is the one thing I would emphasize is the junior analysts that are also graduating right now and are trying to look for jobs do not have or have not adopted some of this AI transition that has happened in the last year or two, right? And as long as you figure out a way to supplement those skills, I think you'll be fine, because all companies that are looking for junior analysts, if I were to have two analysts, one without AI exposure and one who can actually use some sort of an AI capability to deliver things quickly, I would be leaning towards hiring that second candidate and not the first. I do not know if that answers your question.
Yeah, it is kind of difficult. I mean, here, do you want to?
Yeah, that answers my question to a sufficient extent.
Yeah.
Yeah, I definitely agree that. I mean, I don't know what your experience, but I feel like that is kind of hard to know exactly what things will look like because AI has changed so much. Like every month, there's
Right.
a new development, pretty much.
Yes. But fundamentally, what has not changed is the ability to use that as a supporting mechanism to do your function better.
Yeah, for sure. Any other questions? Okay, I think that's everyone then. All right. Well, I thank you again for coming. I really appreciate it.
Of course. And I do want to say that, oh, please, no need for an applause. No,
Okay,
thank
no,
you.
give him an applause.
No, I do want to say, no, thank you. I do want to say, if you have any questions about the vulnerability management, cyber analyst side, pen testing, and um, security advisory, I do have exposure to multiple domains. I'm more than happy to come talk to you guys more, if not anything else, just in terms of what does it mean specializing in an area that you might be wanting to. If you don't know what you want to specialize in, but you are in cyber and you're trying to figure out where to go, please, I'll be happy to help.
For sure, we really appreciate it. We can probably figure out in like another time next semester. I think people would be interested. Like, I know there's a lot of red team interest, blue team as well. So stuff like that, I'm sure people would be interested in hearing about.
Yeah. Well, talking about that, there's also purple team. I don't know how many of you have heard of purple teams.
Yeah, I think so. We have.
Yeah.
I don't know if we
Okay.
have it this semester, but last year we had a competition that did have some purple teaming on it.
Oh, there you go. All right.
All right. Thank you again for coming.
All right. Thank you. I'll have a good Friday.
You too.
All right. Thanks. Bye.
Hello, everyone. That's all we have for today, actually. So thanks for coming in. Hey, if you opened up any of the wells in the ground, please make sure you close them. I will find you if you don't. So.
Presentation.
Bye, stream.